Greetings, this is Mr. Caslin. Today we're going to work on solving what's called a system of equations. That's just a fancy way to say we have two equations, two variables, and we're looking for the ordered pair, the xy, that's a solution to both of these equations. Okay, so we're going to use what's called substitution. In the substitution method, what you're looking for is you're trying to get one of these equations to say y is equal to some expression, or x is equal to some expression. It doesn't matter which one. Do the one that you think is going to work out easiest. Okay, so I'm looking at my two equations. I'm trying to get this pattern. Y is equal to some expression, or x is equal to some expression. In this case, I would try to isolate this y. Solve for this y because there'll be no dividing involved. Okay? So always solve for the one that doesn't have the number in front of it. It's got that hidden coefficient of 1 in front. Okay, so to solve for y, we're just subtracting 2x from both sides. Okay, so down here we're going to get y is equal to negative 2 minus 2x. Now those are not like terms. You can't combine them, but you can list them separately. You can list it as negative 2 minus 2x or negative 2x minus 2. Okay, so we have this pattern here. We have y is equal to some expression. Okay, now what you're going to do is take that expression. You're substituting, right? What happens when you get a substitute in class? They take your teacher away and they replace him with somebody else. Or they replace her with somebody else. So that's what we're going to do. Wherever we see y, we're going to replace it with this expression. So we're going to take it and we're going to replace the y in the other equation, the one you haven't used yet. Okay, so this y we're going to substitute with negative 2x minus 2. So we're going to rewrite this entire first equation. 4x plus 3 times, and when you do your substitution, put that entire expression in parentheses is equal to 0. The purpose of this is, notice we have one equation with one variable x. We can solve for x. Figure out what that is. Okay, so now you just finish solving your algebra equation. You're going to distribute 4x positive times negative is a negative 6x. Positive times negative is a negative 6 is equal to 0. Now these are like terms are on the same side, so you just do that subtraction. 4x minus 6x, negative 2x. To get rid of this negative 6, we're adding 6 to both sides. Okay, adding 6 to both sides, it ends up as a positive 6 on this side. Divide by negative 2. Okay, so you get x is equal to negative 3. Alright, we're not done yet. Remember, we're looking for an ordered pair. Okay, we're looking for an ordered pair, xy. We know our x is negative 3, and we're still looking for our y. Okay, we're going to substitute again. You know x is equal to negative 3. Just substitute negative 3 into either one of the equations. Okay, I'm going to continue here over on this side. Get 2 times negative 3 plus y. Excuse my writing, I'm still writing with a mouse, not very good at it. Equal to negative 2. All I did was stuff this x equals negative 3 into that x. Okay, now take this an algebra equation with one variable, solve for y. Get negative 6 plus y is equal to negative 2. Add 6 to both sides. Those would cancel. Add 6 to this side, you're going to get y is equal to 4. Okay, so that's our entire solution to the system of equations. X is equal to negative 3 and y is equal to 4. Now it's always good to do a check step. If you plug these into these equations, remember it should be a solution to both of these equations. Okay, I'm just going to do that quickly. Negative 3 times 4 is negative 12. 3 times 4 is 12. 12 plus, negative 12 plus 12 is equal to 0. That checks. It should check into both. Negative 3 times 2 is 6. It's a negative 3, so it makes it a negative 6 plus 4. Negative 6 plus 4 is negative 2. Negative 2 is equal to negative 2. So that checks. Okay, so the key was to solve one of these to get y by itself and substitute that expression into the other equation. Solve for one of your variables, and then you can solve for your other. Okay, now there's different types of problems. This one's a little trickier. Notice none of these variables have a coefficient of 1 on them. Okay, so this problem is a little bit trickier. So, but we're just solving for y. Let's try this one first. 2y is equal to negative 5x plus 43. Now I hope you realize what I just did was I just subtracted 5x from both sides of my equation. Okay, to get y by itself, I'm going to divide by 2. These cancel. Y is equal to negative 5x over 2 plus 43 over 2. Now, we've got some really ugly fractions here. I would actually stop right here and say, if we take this expression and stuff it into here, okay, that's going to be a little bit harder because of all the fractions that we have. All right, so what I would do is try the other one then. That one's not looking too good. Let's solve this one for y instead. Okay, I have a negative 6x. To zero this out, I have to add 6x. Okay, so I'm adding 6x to both sides. 6x minus 30. You could call it negative 30 plus 6x, the same thing. Okay, now in this one, if we divide all the terms by 3, this is much cleaner. We get y is equal to 2x minus 10. Okay, remember we were trying to get that pattern, y is equal to something, so we've got it. So we're going to take our equation, and remember we're going to stuff it into the equation we haven't used yet, which is this top one. Okay, so now the same process as the last problem. You're going to get 5x plus 2 times 2x minus 10 is equal to 43. All right, now you have an algebra equation. You have one variable x, and you're solving for x. I mean, some of you are looking at this saying, well, there's two variables. Well, it's the same variable, so we know we just can combine those x's here in a second. So we have 5x distribute plus 4x minus 20, 2 times negative 10 is equal to 43. Okay, same side variables, so 5x plus 4x, common like terms, just call that 9x. To get rid of this negative 20, I'm going to add 20 to both sides. Okay, if I add 20 over here, I get 63. Divide by 9, x is equal to 7. Now I'm speeding through this equation solving because I assume at this part of Algebra 1 you already know how to do this. Okay, so x is equal to 7. All right, now same as the last problem, just take that x is equal to 7, substitute it back into either of your equations up here. We could plug that 7 into here. That might work. Okay. So we do 5 times 7 plus 2y is equal to 43. This is going to be 35. I'd end up subtracting 35 from both sides. 43 minus 35 is 8. I get 2y is equal to 8. Divide by 2. Y is equal to 4. Okay, so when you're doing this for your teacher, make sure you really explain what your final answer is. Remember, your answer is an ordered pair. X is equal to 7, y is equal to 4. Box it, highlight it, circle it, whatever, so your teacher can see the answer clearly. 7, 4. Remember, the other thing this is saying is that these are linear equations. These are two lines. If you were to graph these lines, these two lines would intersect at this location at 7, 4. All right, good luck. This is a video, so if I went through things quickly, just rewind and watch them again. Good luck on substitution, and look for my next video, which will be on elimination. Good luck.